If x and y are independent and normally distributed, then a linear combination of the two is also normally distributed, where the mean is the linear combination of the means, and we should write subtractions using a negative coefficient, but it doesn't really matter. For example, if z equals 3x minus 2y, we should write z as 3x plus negative 2y, and so our mean will be, but notice that's the same as if we just subtracted the means. However, the variance always adds, and so it's important to keep in mind that we do need to rewrite that as adding a negative, because when we square it, we're just going to add the variances. So, for example, maybe we have a useful life of 10 years and a standard deviation of 3 years, and let's find the probability that the total useful life of 2 randomly selected refrigerators will exceed 1.9 times the life of a third. Let the refrigerator lives be modeled by x, y, and z. What we want is the probability that x plus y is greater than 1.9 z. Now here it's useful to always compare to a constant. So let's define a new variable that includes all three of these that will become the inequality we want. And so if we define w equals x plus y minus 1.9z, we can look for the probability that w is greater than 0. So the mean will be the same linear combination of the means, that's the mean of x, plus the mean of y, minus 1.9 times the mean of z, and that will give us the variance always adds. So our variance will be the variance of x plus the variance of y plus 1.9 squared times the variance of z, because scalar multipliers come out as squares. And so the variance will be and so the standard deviation will be the square root of the variance. And we want to find the probability w is greater than 0, so we'll get the z-score, which is and z greater than a negative is the same as z less than a positive, and so we find. And if we need to, we can interpolate to find a more accurate value, but we won't. Or we could take a more complex problem. So here we have 20 loads of coal being added and 4 loads of coal being removed, and we want to know if the amount added is going to be greater than the amount removed. So let x1 through x20 be the amounts of coal added, and y1 through y4 be the amounts of coal removed. Then the overall change will be, and so our mean will be as for the variance, so we'll be adding 20 variances of x and then adding 4 variances of y. And so that gives us, and so our standard deviation will be, and so the change in the amount of coal will be normally distributed with mean 1, standard deviation 1.5, and we want to find the probability that the change is positive. And so we'll find our z-score. It's symmetric, and so we get